Okay, so I'd like to take a look at surface area and volume with you. This is actually often considered to be a fairly hard topic in geometry because there's just a lot of steps. Prior to a geometry class, the majority of problems that we do only take 2 or 3 steps, maybe 4 on the outside. This is one that is way more than that. And it's not like every step is all that hard, but there's a lot of little things to keep together. So anyway, if you're struggling with that, it is sort of understood that that would be the case. So here we go. So what I have right now is a shape, and you'll notice that when we deal with that, anytime you have a situation where you have two faces like this, a top and a bottom that are parallel to each other and congruent, that is known as a prism. So we have a prism that we're going to be studying right here. And the name of that prism is based on the name of the base. And since this is a hexagon right here, this is called a hexagonal prism. Now, again, one thing that is really, really important is we are using this one. This is supposed to be a regular hexagonal prism. And what that means is that all of the sides of the hexagon are the same and all the angles are the same. Now, there's nothing in the picture to tell you that that's true. You have to be told that or given some version of a way to establish that. But if I actually labeled this picture to make it look right, the labeling would make the picture very, very difficult to understand. That's why I chose not to do that. I stripped that information off of here. But here's how we're going to start that. What I like to do is I like to go up here to the top, right, like this, and draw a simple triangle, okay? Now, keep in mind, I'm drawing a triangle, and this is in 3 dimensions, so it's going to look a little bit awkward. But you'll notice that what I've done is I've taken that hexagon and say, I'm going to take the hexagon, and sometimes what I'll do is I'll actually tip it up to the side so I could look at it head on. And I'm looking at this triangle right here. This is the one that I'm interested in. Sorry, my allergies are kicking in here a little bit with all of the stuff that's going on now. These are the same story. So that's how I personally tend to like to do it. Now, what I know is since it's a hexagon, if we took 360 and instead of dividing by 6, because it has 6 sides, I'm going to divide it by 12 because keep in mind this triangle really was not a triangle in which I did the whole thing. I did half of it. So 360 divided by 12 is 30 degrees. Now, the reason I wanted to highlight this particular story is that means this is a 30, 60, 90 triangle. And again, we haven't studied that in a little while, but in a 30, 60, 90 triangle, you want to remember that anytime you have a 30, 60, 90, whatever the short side is, the hypotenuse is twice as long, and the long leg is the same as the short leg multiplied by √3. So that's actually extraordinarily helpful for this particular problem because I know that if this entire length is 8, then this piece is 4. And therefore, this piece right here is 4√3. Now, again, what I want to do is I want to start by finding the area of the base. So let's find the area of the base, which is the area of this big hexagon right here, which remember the area of the hexagon is really the area of the triangle multiplied by 12 since we have 12 such triangles. But the triangle itself is 1/2 its base, which is 4, times its height, which is 4√3. And again, we're still going to multiply by 12 because we have 12 such triangles. Well, what's kind of nice about this particular situation, oh, somebody put something silly on that calculator. I don't like it when there's a background picture, but 0.5 times 4 times 4 times 12. Notice that I'm ignoring the √3 for a minute because it's going to be problematic. But my base is 96√3. So the area of this entire thing is 96√3. We're going to get to everything here in just a moment. I also wanted to mention that this side right here, which is one of what we would call a lateral face, That face is 8 by 6, which is, of course, 48. So each one of these faces, as we work our way around, is 48. Sorry if that doesn't look like 48 because I shaded. Okay, so now let's take a look at the story. And our textbook does this differently than we do. Our textbook does surface area as one story and volume as a different story. But I really like to put them together because if you know one of them, you're going to know the other one very, very quickly. So let's start off with the surface area. So the surface area starts with the fact that you have a top, but you have two of those because the top and the bottom have exactly the same area. Plus, you have one of these sides over here, which is 48, but in fact, I have 6 of those sides. So if I did 2 times 96, I get 192 roots of 3. And of course, 6 times 48 is 288. And all of that would be 288. And again, that would be in units squared. So surface area is very simple because we literally just break it down into pieces and find the area of every single piece and just add them together one at a time. Now, interestingly enough, the volume is actually an easier story, which is not what you'd expect. Usually when you go up a dimension, it gets harder. But volume is always the area of the base, which we already found, times the height. And the height is defined as the separation between those two faces. So it would be 96 roots of 3 multiplied by 6. But again, 96 times 6 is 576 roots of 3, but this one would be units cubed. And we are done. We just found the surface area and the volume of that hexagonal prism, and we needed the fact that that was a 30, 60, 90 problem. You're going to notice one down here that is not a hexagon. That'll be for another video where we have to use a little bit of trigonometry. All right, thanks for joining me. Thanks for trying hard to learn. Okay, bye. See you back in class.